In our everyday life, we make number of statements and most of them are qualitative statements. Like Mr. Desai is taller than Mr. Venkatraman, or my uncle's house is much further away than my school is. These sort of statements are quite common and we are familiar with. But in physics, or for that matter in science in general, qualitative observations, qualitative information are important, but finally we really need to have some quantitative information. And particularly in physics, quantification is the buzzword. When we talk about quantification, we need to take measurements. As I have just mentioned about my uncle's house, distance of my uncle's house from my place, or distance of my school from my place, I have to mention the distances to properly communicate that information to the others. Suppose I tell others that my school is 1 kilometer away from my residence, while my uncle's house is 6 kilometer away from my residence. This is a quantitative statement and it contains much rich information, much more important information. Since the quantification is a very important exercise, we can only quantify through measurements. For example, if we can measure the height of two persons, then I can say that, well, this person is having this much of height, so he must be taller than that person. And similarly, if we can take the measurement of mass, we can make the comparison in a more systematic way. And information, quantitative information is also very easy to communicate. Now, historically, people really undertook measurements long time back, and gradually people felt the necessary for standardization. That means the measurement should be such that it can be understood by everybody. It is not like that he is having a land which is 7 cubits long, then this cubit is something which people used to use earlier, but that did not communicate the right kind of information or standardized information. So, now what we really do? We take measurements and we communicate that to the others to convey quantitative information. The very three common measurements are the measurements of length, measurement of mass, and measurement of time. There are of course a large number of physical quantities. Not all of them are really being used in our everyday life, but we need to measure them, and whenever we need to measure them, we need something more. For example, if I use this scale to measure the length of a table, say a table right before me, I have to use it in the right way. That means, if I want to measure the width of the table, I must place it along the width, read the both ends correctly, and then of course cover the other part with once again placing the scale. This may not be a very good way of measurement, but still it gives us some more or less acceptable information. Now, we also know a very interesting thing, that if I really give you a scale and ask you to get the mass of that, say pen, mass of this pen, you really cannot do it with the help of this scale, because that demands a different type of instrument. So, all the physical quantities cannot be measured with the help of one single instrument, or one single type of instrument. Even for length, if you were asked to measure the length of the football ground of your school, this scale is not a suitable one for that measurement. You will have to take long measuring tapes and you will have to measure that. On the other hand, if I ask you to get the diameter of a thin wire, then once again this scale is not a suitable instrument to do that. Although for the length of the football ground, length of this table, or for the diameter of a wire, all things are the lengths. You are essentially measuring the length, but you really need different types of instruments to have a reliable measurement. Once you have measured a particular physical quantity, it has to be expressed. And for expressing a physical quantity, we need two things. Number one is a number that carries the information about its size along with the unit that also indicates what type of physical quantity it is. For example, if I say the width of this table is 72 centimeter, then I am talking about 72, which is a number, and centimeter, which is a unit. These two taken together provide the complete information about the width of the table. But of course, we have to remember, instead of 72 centimeter, if I put it in meters, that means if I change the unit, this will come out to be 0.72 meters. So, the number essentially depends on the unit you are choosing, but we have to remember, for the expressing a length, we have to in any case choose a unit of the length only. We cannot say express length in terms of the unit of a mass or time. Similarly, let us have a look at this digital balance. Now, I am having a pen with me. If I put this pen, you can see initial reading is 0, nothing has been put in. Now, I put the pen and you can find the mass of the pen is coming out to be 8.08 gram. Now, if I put another pen, normally these pens look alike, they may have more or less same weight, and you can expect a total mass in the neighborhood of 16 grams, and have a look at it, you have got it as 16.09 grams. Now, this is an instrument for the mass measurement. Once again, you can understand this small electronic balance is a quite delicate one. You really cannot put up a huge weight, like say you cannot really take up the chair from your classroom and put it over there to get its mass. You will not be able to do that. It has got a limited range. So, once again, for measurement of mass, we are having some special devices. Those are known as, they may be ordinary common balances. You can see them in the local markets, local shops. Beam balance we call them. Electronic balances are also widely used. There are furthermore instruments for the measurement of mass. Quite often, mass and weight are used in a loose way and appear to be synonymous, but there is a difference. Without highlighting in that difference, I can say there are other devices like spring balance for the measurement of weight. Now, once again, since we have expressed this in grams, the number has come out to be, for a single pen is 8.09, for 2 pens it is 8.08, 16.09 grams. If you expressed it in milligrams, how will it look like? Since a milligram is 1,000th of a gram, we will have to multiply the number by 1000. So, it will be something like 16,000 milligram. On the other hand, if we go to kilogram, it has to be divided by 1000, because we know 1000 gram can make 1 kilogram. Let me tell you, these are the things where when we are talking about kilo and gram and getting kilogram, we are talking about milligram. This kilo and milli, these particular prefixes are known as SI prefixes. The biggest advantage of SI system is that by employing suitable prefixes, we can change the unit in multiple of 10, sometimes in multiple of 100, maybe a multiple of 1000. If I really want to have 1 kilogram, essentially it is 1000 grams. Similarly, if we want to have 1 quintal, that comes out to be 100 kilograms. And we can go on like this. There are SI prefixes like we are quite often familiar with, in different contexts they are being used. You can see the chart that is being displayed here, that if we go on using suitable prefixes, we can scale up the SI units. If we go by the steps of 10 to the power 3, after gram it is 1000, 10 to the power 3 is kilogram, and 10 to the power 6 comes out to be mega, then 10 to the power 9 comes out to be giga, and 10 to the power 12 comes out to be peta. It goes on like this. Sorry, 10 to the power 12 comes out to be tera. Now, if we really look at the lower side also, similarly, by using the SI prefixes, we can really go down the unit. 1 gram becomes 1,000th of a gram, and we call it milligram. Then it becomes again divided by 1000, gives us microgram, 10 to the power minus 6 gram. Then it goes to nanogram, and then it goes to your picogram, and this way we can have very easy movement of the SI units. And it is not only for gram, same exercise can be done for meters or any other suitable unit. Now, there is a third quantity which is known is the time. One of them, there are so many other physical quantities I have already mentioned, but time is very common and we measure, and quite often we need to measure the time with the help of a wristwatch, and time intervals, that is the difference of time between two events, we often try to measure with the help of a what is known as stopwatch. Stopwatches are quite often nowadays available. They are built in these mobile phones, and these mobile phones can be used as a stopwatch. For example, if I really start, an event starts now, and if I really start this stopwatch, it will go on giving me the time, and if I after some time, if I say the event has stopped, that event may be oscillation of a pendulum, that event may be say sliding down of a ball along an inclined plane. There are so many things can happen, and just then if I say stop, I shall immediately get the time that is elapsed between the two starting and finishing of the two events. Finishing of the starting of the event and the finishing of the event. So, these three physical quantities, length, mass and time, they appear to be so familiar with us. They appear to be so useful for our everyday life. We really like to have easy measurement of these three quantities. But there are physical quantities which can really be derived from the measurement of these things. For example, if we can measure the distance and time, say taken by a boy from moving his residence to his school, we can possibly find his average speed. And there are large number of units we use. Actually, they do come in our life, but we are really not very frequently using, and a good number of them, you will be surprised to know, the good number of them actually name of the units come from the name of the scientists. Look at the 220 volt, our supply 220 volt AC 50 hours. This volt comes from the name of Alexander Volta, who was an Italian scientist, and he basically found out first what a current electricity could be. Then comes ampere. We quite often say 15 ampere plug, 5 ampere plug. This Ampere is a French scientist. His name is associated with the unit of current, SI unit of current. For Celsius, temperature Celsius, we quite often mention that today's temperature is 35 degrees Celsius and it is very hot. This Celsius is once again name of a scientist who was a Swedish scientist associated with the temperature scale. Similarly, Fahrenheit is another scientist. Look at the watt. We are putting a 9-watt bulb or 23-watt lamp in our rooms. This watt comes from the name of James Watt. So, this way a good number of scientists' name has been incorporated in the units. We have to remember that measurement is incomplete until unless we express that measurement in proper number and proper unit. And moreover, we should have some idea what sort of instrument we shall really need for a particular measurement. Sometimes we are possibly doing that by intuition or by practice or by just we are following a tradition, but in science we will have to learn them specially, and there lies the importance of measurement. Thank you.